Alright, so today we're going to continue our discussion with triangle proofs, but now we're going to go beyond just proving triangles congruence. We use something called CPCTC. We're also going to talk about how circles can be used in these proofs. Now, one area we're going to use our circles are if dealing with the concept of the radii, plural of radius, of a circle are all going to be congruent to each other. This is going to be useful where if I have a triangle inside my circle that uses the radii as sides, they all must be congruent to each other, and I can use that information to help prove triangles are congruent. So the reason why I would say if we're going to use that is that radii of a circle are congruent. So CPCTC stands for corresponding parts of congruent triangles are congruent. Now we use this after we prove two triangles are congruent, because as we know when we first discussed congruent triangles, that meant that if two triangles are congruent, all three angle pairs are congruent to each other, all three side pairs are congruent to each other. And in all our proofs, we only need to find 3 of those 6 pieces of information. 3 sides, none of the angles, 2 sides and an angle between, so on and so forth. So I can use CPCTC to say afterwards, well, whatever remaining pieces I want to use, they have to be congruent because they're corresponding parts. So for example, I'm given triangle situation right here. We're given that BD is perpendicular to AC, and that AB and BC are the same length. I want to prove that angles 1 and 2 are congruent. Now, the only ways to prove triangles are congruent, angles are, is if the 2 of them are vertical angles, which they're not. If 2 of them are both right angles, which they're not. If I have parallel lines and they're alternate interior, corresponding, or alternate exterior, which they're not. Or if I have an angle bisector, which I don't. So the only other way to prove that, well, these 2 angles are in the same spots in both their triangles. So if I could show the 2 triangles are congruent, I could then say that the angles are congruent because they're corresponding parts. So we'll start with our given statements. We recognize that for both the triangles, they share this reflexive side BD, so it has to be congruent to itself. Now, if BD is perpendicular to AC, what that means is we have 2 right angles. Angle 3 and angle 4 are right angles, because that's our definition of perpendicular lines. Now, as we discussed last time, once you have right angles, you need to look at your diagram. Do I have the hypotenuse of the diagram of both triangles congruent? Because if I do, I can probably use my HL theorem. And I do have it. So because I actually have the hypotenuse, I don't need to say that 3 and 4 are congruent. I can stop and go immediately to triangle ABD is congruent to triangle CBD because of HL, hypotenuse leg. I have the hypotenuse and each triangle congruent to each other, plus the leg, and it's a right triangle. So, now that I have the triangles are congruent, angle 1 and 2 are both corresponding parts. Therefore, I can now say right after triangruence, angle 1 is congruent to angle 2, because the corresponding parts of congruent triangles are congruent. CPCTC. So that's the whole point of this. We still need to prove triangles congruent, so everything we did last time still needs to happen. But now we're going one step beyond. We're now saying, well, now the triangles are congruent, this is true about the angles. This is true about the sides. So here we have circle H. So this is telling us that H is the center of the circle, and that 1 and 2 are both congruent to each other. We want to use all this to prove that EF and FG must be the same. So we have our given statement. Well, if H is the center, EH, HF, HG must all be congruent to each other because those are all radii of a circle. This particular circle at least. So HE, HF, HG are congruent because radii of a circle are congruent. Okay? Now we have everything we need, because now I have 2 pieces of sides in each triangle plus the angle in between. So triangle EFH is congruent to triangle GFH by side angle side. And now the triangles are the same. EF and FG, if you notice they're in the same spots. EF is congruent to FG because of corresponding parts of congruent triangles are congruent. CPCTC. So that's how we're going to use circles in our triangle proofs. And it's a horribly drawn circle, I'll grant you that. It was hand-drawn. So for this diagram, we are given that C is the midpoint of AE and BD, and we want to prove that angle 3 and 4 are congruent. So I need to show the triangles are. So we'll start with our given statement first. Now let's use the information. According to the diagram, angle 1 and 2 are both vertical angles. So therefore they're congruent. According to the given statement, C is the midpoint of AE and of BD. So since we have a midpoint, we can say AC is congruent to CE. We can say that BC is congruent to CD because of our midpoint theorem. And now I have all the information I need to say the two triangles are the same. So triangle ABC is congruent to triangle EDC by side angle side. And now, because the two triangles are the same, I can say 3 and 4 are congruent because CPCTC, corresponding parts of congruent triangles, are congruent. For this particular proof and other proofs, you need to be very careful when not assuming information you do not have. It looks like 3 and 4 are both alternate interior angles because they form a backwards Z. And while that would be true, we do not know that AB and DE are both parallel, so we could not say that. That's why we had to instead prove the two triangles are congruent to show that 3 and 4 are the same because they're corresponding parts. So you need to be very careful assuming information that's either not given to you or not explicitly stated in the proof itself. So you need to watch out. Now in this case we are given parallel lines. FG is parallel to HI and FI is parallel to HG. We want to use that to prove that FG and HI are both going to be congruent to each other. So again, given statement first. Now, if I do have parallel lines, FG is parallel to HI, that means 1 and 2 are congruent. And if FI is parallel to GH, that means 3 and 4 are congruent. So I can say angle 1 congruent to angle 2. I can say angle 3 is congruent to angle 4, because they are both alternate interior angle pairs. Now I need a side, and I notice they both share side FH. So I can say FH is congruent to FH, because that's our reflexive side. Now I have everything I need. I have two angles in each triangle, and the side in between. So we can say triangle FHI is congruent to triangle HFG by angle, side, angle. And we can now notice that FG and HI are both in the same spots. They're both corresponding sides. So I can say that FG is congruent to HI because of corresponding parts of congruent triangles are congruent. CPCTC. Alright, just one more proof we want to give us a try with. And actually I want you to try this one on your own. See what you can, fill out the entire diagram, use the given statements. We know that NO is congruent to MP. Angle 5 is congruent to angle 6. Use the given information to prove these two triangles are congruent, to then say 3 and 4 are congruent because they're corresponding parts. So go ahead and pause the video, and then I'll go over it with you. Alright, so this is what your proof should look like. You only need one more piece of information. You had a side pair and you had an angle pair. Well, if NO is parallel to MP, when you're given parallel lines, you should look for Z's and F's. And we have an F right here, which forms with angle 1 and 2. So that's why 1 and 2 are both congruent, because they're corresponding angles. Once we say that, we can now say the triangles are congruent because we have two angles, and the side that's not in between, but it's in the same spot. That's angle, angle, side. Now once I can say that, that leaves just 3 and 4 must be congruent then, because they are corresponding parts of those two congruent triangles. Okay, so that's how you use corresponding parts. You're still proving triangles are congruent, so you need to always do that at the very least. Do that part first and then go from there. We have one more section to talk about in this chapter. That's going to deal with going beyond corresponding parts, proving that we have an angle bisector, proving we have parallel lines, proving we have a midpoint, stuff like that. So I will see you next time.